The overall goal of the following experiment is to synthesize alkanethiolate stabilized gold nanoparticles known as monolayer protected clusters or MPCs and assemble these materials into thin film assemblies that are used as an adsorption interface for azurin protein monolayer electrochemistry. This is achieved by first protecting gold colloids with organic ligands to create gold nanoparticles surrounded by an alkanethiolate film. Next, the MPCs are anchored to gold and glass substrates and networked into thin multi-layer covalently linked films whose growth is tracked via optical and electrochemical measurements as well as cross-sectional microscopy. Then, the electron transfer protein azurin is adsorbed at the interface and cyclic voltammetry is performed for protein monolayer electrochemistry. The results show that the MPC film interfaces created by this procedure allow for more optimized electrochemical analysis of adsorbed protein based on the MPC film, providing a more homogeneous adsorption interface and fast electron transfer kinetics that lack traditional distance dependence.
The main advantage of this technique over traditional protein electrochemistry is that electrodes modified with nanoparticle films provide an adsorption interface that results in a more ideal electrochemical behavior as measured by cyclic voltammetry.
Visual demonstration of this method is critical, as the synthesis includes important visual cues, while the film construction and characterization involves multiple intricate steps and analytical techniques.
MPC films can be assembled on modified gold electrodes or glass slides by using a dip cycle method of alternating MPC layers and dithiol linking molecules, and consequently these layers can be tracked electrochemically.